So, hello. As you said, my name is Benedicte, and I'm a full-stack JavaScript developer from Oslo, Norway, so still Europe. And today I'm going to share with you what I learned so far about encryption and more importantly, key management when it comes to encryption on my quest to figuring out how to make a privacy-first period tracker or menstrual cycle tracker. It depends on what word you use. I hope I can help lower the bar when it comes to encryption, so that maybe you also will use encryption in your next side project and maybe later at work. But first, we'll have some story time. For years and years, I've been able to keep consumer Benedicte away from developer Benedicte. Consumer Benedicte has been using apps and services like most regular users. You know, I have nothing to hide, and if I did, I just don't have the time. But then, to care about it. But then, this winter, the first kind of major leak that health apps, and especially menstrual cycle trackers, were leaking data to Facebook through Facebook Analytics. And later, just a couple of weeks ago, a new report came out where they're intentionally sharing that data with other people, some companies selling it and some using it for research, which is a good cause, but it's still something we need to know about as a consumer when we make choices. So Benedicte, developer Benedicte and consumer Benedicte had to have a little talk. Because right after this leak came out, my period tracker, Clue, which is one of the nicer ones, sent me this email. And it says that only a few people have access to the tools we use to look into the databases. And that's the point where consumer Benedicte realized, what developer Benedicte has always known, and that's this data is just there in plain text. I mean, it's in the database, and somebody needs to have access to that database. And it could be any of you, it could be me, it could be my friend from university. And with some types of data, that could just be, very awkward conversations, or not trying to pretend that I haven't seen the data. So for me, it kind of hit home more personally when I started thinking about that scenario than kind of the big data scenario. So in the back of my mind, I've always felt like these apps have been very invasive. They're very detailed. They don't care about only when my period is. It's how much and for how long and all these kinds of weird questions. And my friend who's been single for months, she's tired of getting the question every day is have you had sex? She's like, no, not yet. And there's been this thing in the back of my mind. It's why are they so invasive? And I've realized, of course, it's because they're going to use this data for something else. So they need a certain kind of detailed level. So my idea of so in the back of my mind, I've always wanted to make a less invasive and less detailed app that would fit my cycle better. And I thought if I was ever going to make this, I need to learn how to shield myself from my users' data. I want to be one of those can't be evil apps. I don't want to be the one don't be evil. So I sat down and I did what any sane developer would do, is that I made the proposal that got me on the stage today, stating I'm going to learn what I need to learn to make a privacy-first app. So that's what I did. And also, while I was, like any other sane developer do as well, while I was procrastinating finishing these slides, I actually took a stab at making the app. So it's called POW, and I launched it on Product Hunt. It's a very minimal version, and on the same day that new leak came out, so could think that I actually had an agreement with these journalists, because it was just hours after I released POW on Product Hunt. And the support and attention has been it's blown my mind. People are really interested, they really want such an app, so I've decided to just keep focusing on actually making the app, and we'll try to launch on March 8th, 2020. And for those of you who don't know what that day is, it's the International Women's Day. So I'm happy to say it seems like privacy is becoming more mainstream, and people are getting interested in knowing where their data is going, and also maybe having a say in where it's going. Before I go into encryption, I just need to thank Jeffrey isn't it Jeffrey? Jeffrey from 1Password. It was really hard trying to find information on this topic from a web app perspective. There's a lot of more theoretical knowledge, but the only real content I found on how the full flow of a web application goes, it's this security white paper by Jeffrey, who works at 1Password, which is a great app. So if you want to look into it more after my talk, which is very introductory, you should try to read this white paper. And I'm a noob. I just learned this, and I'm going to try to explain how to use encryption algorithms. I will not go into how they actually work. Should not try to make your own encryption. That is something that will take about 20 years to be able to do if you're going to do it on a state secret level. Yeah, you first need your PhD and then about 15 years of experience, and then you're allowed to make encryption, so that's not for us. And I will not go through all the attack vectors. I will look more into how would you actually do it, because that's what I found lacking. So I have a Master of Computer Science, and I remember talks about encryption, but I feel like I know I knew too little about it. And I'm still, as I said, in awe of the people making encryption algorithms, but we're going to go and look at how to use them, and especially key management, as I realized using the encryption algorithms are fairly easy, but what to do about all the keys, we're going to get into. So this is a basic encryption algorithm or encryption flow. You have your plain text and you have a key, and then you encrypt it, and what comes out is called cipher or ciphertext. And then to get your plain text back, you reverse it through your decryption algorithm. One of the things that I spent an embarrassingly long amount of time to figure out is, what is this key? It's usually just drawn as a key the same way I did. And I was like, this key, it's this sort of magical thing. But it turns out it's just a very long sequence of characters. But you use different algorithms to make them for specific, or you generate them for specific algorithms, but basically they're just long random strings of characters. And it turns out that long random strings of characters is really important in encryption, and so they even have a word for it called entropy. And because if you have something that's easy to guess, then the whole thing would fall apart. Then you would just guess the key or guess the password, and encryption would fall apart. And if you now, we're JavaScript developers, if you're thinking math random right now, then that is not a true random algorithm. That's something called a pseudo-random. They give you pseudo-random values, but what we need is cryptographically strong random values. Before showing a code example, we're going to look at an analogy that's often used in the crypto world. A way to think about encryption is how we secure our belongings by locking them into our house. Only somebody with the correct key can unlock the door and get a hold of your belongings. The big difference, though, is we lock something inside, while with decryption, we actually transform your belongings. So the furniture would no longer be there, it would be something different. But we're still going to use this analogy because it's used a lot, and it's easier than transforming things into different substance matter. So luckily for us, the browsers now come with Web Crypto API embedded, so we don't have to do any crypto stuff ourselves, as we should not do. And the first thing we need to do is make that key that we saw in our encryption algorithm. And before we can make the key, we need to decide on what encryption algorithm to use. And from what I've gathered, this is the algorithm we want, the advanced encryption standard with Galois counter mode. So we start by generating a key for that algorithm. And here we say that we want the length to be 256 256. But it could just as well be 128. And Jeffrey from 1Password has a long blog post about it not really being that, it's not that much more secure with the 250-bit encryption, as it's called, as 128-bit encryption. It's like going from infinity to infinity, he says. But for the users, they like the sound of 256 over 128. It just sounds more secure. It sounds better. So I found that also in security, there's a lot of usability issues, and it's not only like the hard science that they might want you to believe when you read most of their literature. So we have the key. Now we're going to encrypt our little note. And as some people might notice, we're not allowed to work on strings. We have to make buffers, which I find quite annoying, because that's not something I usually do in my day-to-day work. So as we saw in the diagram, we input the key and the note, and out we get cipher. But there's another thing here. In addition, it's called installation init vector. Because to counter against something called cipher attacks that I don't totally understand, we need a different random value as well. But we could save that together with our ciphertext, because it does not have to be secret. So we generate it here with that cryptographic safe random value generator. So it has to be unique for every piece of data you encrypt, but it doesn't have to be secret. And to get our note back, we decrypt using the same installation vector, the key, and we have our ciphertext. We get the buffer back, and then we make it into our string again. So that was basic encryption. We generated the key, the red key, we encrypted our data, and then we decrypted our data again. So I was very pleased with myself when I got this far in my exploration, but I quickly realized that there's a lot more to it. I was a lot closer to those two circles than the owl. So I'm going to try now to walk you through how we generate keys and when we use what key to hopefully make you better equipped to read content around encryption. We're going to start by just assuming everything is in your client, your mobile phone, or your laptop. And it's easy peasy. We just save our ciphertext to the local storage. But where do we keep the key? So this is our first encounter with key management. If we stored the key together with our ciphertext, then there wouldn't have been much point in encrypting at all. So let's go back to our house. And in this scenario, we're going to look at a way to do this. So it's a little bit of a stretch, since we would probably not do this with houses in real life, but just bear with me. So in this scenario, we're looking at where we'd actually just like hide the key next to the house. Some people would do that for convenience. Maybe it would be under the flower pot on the veranda, or like a secret spot under the stairs, something like that. It's convenient, but it's not really recommended, because anybody could get in your house if they found the key. So therefore, you decide to get one of those key boxes that are more popular now, especially with Airbnb, where you pop your key into a key box, and then you set a code on the keyed box. And in this way, you can access, only you can access the key with something you remember, not something that's stored anywhere. So to do this, we can do this in our code as well. We can import a key from a password with this function called import key, and we want to use the password-based key derivation function too. We ask the user for their password, and then we transform the password into a key by using this function, and then again we have to encode our strings. And using that password key, we can derive a key. And as the name implies, it's really good at making keys from passwords. But since user-selected passwords are often easier to guess than something we generate randomly, we also need a truly random key, and we add that and we call it the salt. So this function, derive key, is deterministic, meaning that as long as you provide it with the same salt and the same password, the output will be the same. So we can generate it again or derive it again and again. And in our case so far, we would have to save that salt together with our ciphertext. So it doesn't provide, the password provides us with some extra security, but the salt is not giving us much extra right now. But later on, we will see how the salt can shine. So let's get back to our house. There we only had the key lock with the passcode on it. So we need to get one of those key boxes that has a code and a regular lock. I don't think those exist, but that's what we're getting. And then we take that salt or that key for the regular lock and we put that one under the flower pot. So to get in, we need to find the key that we've hidden very secretly under the flower pot. And we need to remember our code. Then we can get our house key and we can get into our house. So that so that was this was our basic encryption. And as you can see, the encryption stays the same, but we're now deriving the key instead of generating the key. So let's move over to cloud storage. So there could be a case where a menstrual cycle tracker app could just store everything locally, but consumer Benedicte has gotten some fancy habits, and she likes her data in the cloud so she can get access from multiple clients and also backup. So we'll keep going on our encryption and key journey. We'll start by what goes where. So we'll put our ciphertext in the cloud. We'll keep our salt on the client, and then everything else is kept in memory. The password kept in, our own human memory, and then everything else in the client's memory. And this looks like this for the user in 1Password. When you're going to move between devices, this is where our salt shines, because you can't, if you pick up a new device, you will need the password, but you also need the salt. So you need access to your other device to get that salt, and you need to manually transfer it. So this gives us some added benefit instead of just hiding it in the flower pot next to the house. And 1Password calls it the secret key, and they also give us a QR code, so it's easier to set up on a new mobile device by just taking a photo. They also really want you to print this out and put it somewhere safe. And they have a little field where you can write in the password that you're supposed to only remember in your mind. And the reason for this is that in these kind of privacy-first focused apps, if you forget your password, then they can't give you any account recovery, because they don't know your password and they don't have access to your content anymore. So you really need the users to remember that password or print both their secret key and their password out and put it in a safe or somewhere, because you cannot give their content back to them if they forget. So it's a very interesting from a user standpoint. We need to help our users to get new mental models about where data is stored and how it's stored, because a lot of people are very used to just hitting the recovery or I forgot my password link. A nice thing with this setup is that something that sounds really fancy, or at least for me sounded very fancy, end-to-end encryption, something that people say whenever they talk about cloud, it's not as hard as it sounds or as special as it sounds. It just means that all encryption and decryption happens on the client. And that's what we're already doing, so we have end-to-end encryption down without much extra effort, or with no extra effort. Again, you might say, what does sharing have to do with a period tracker app? And over these last weeks of making the app and started talking about menstrual cycles, I've talked more about cycles with my friends and other random people than I think I have in my lifetime combined. And this idea that I've had, that we've had at home, where I maybe want to share some of my data with my significant others. There are parts of the days in the cycle where I don't really want to communicate as a regular human. I just want my app to do it for me. And other people, some people think it's a horrible idea, and other people love it. So we're going to go with the people who loves it, and we're also going to share some of our data. So to share data, we need some different encryption flow, and it's called async encryption, because I always have a problem saying asynchronous encryption. And in this type of async encryption, there's a different key for encryption and decryption. So you'll see we have the orange key, old school looking key there on the left, and the purple on the right. You could switch these up and use the other one for encryption and the first one for decryption. And this was really hard for me to understand in the beginning, because they're usually labeled public and private. So I thought it was always the public that had to encrypt and the private that had to decrypt, or the other way around. But you can switch these up, and they have different use cases. But for our use case, this is the one we want. We want to encrypt with the public key, which is something that you can freely share, and then we want to decrypt with the private key. So let's go back to our houses. You now have a neighbor, and the neighbor has very complementary tools to use. You want to be able to share your tools with your neighbor, and she wants to share her tools with you, which is really nice as a nice neighborhood. But you don't want to always have to be at home when she comes over, and you want some way to coordinate the sharing. And you could just give it to her in the physical world, but this is a special case. Well, anyway, so you can put all of your tools, and she can put all of her tools in your respective sheds. But how are you supposed to be able to give her the key if you don't have time to meet her in person? One way to do that is that all the neighbors have lockable mailboxes. So you can take a copy of your shed key, and then you can drop it in her mailbox, and she will be the only one able to unlock that and get the key to your shed. And the same the other way around. She could take a copy of her shed key and drop it into your public mailbox, and then you will be the only one able to open it with the key to your mailbox. But then we have a key again, so you have the key to the mailbox, and what should you do with this? Well, we'll put it into that key box again that has a code, and then it has the lock, and then you put that key under your flower pot. And to generate these async keys, you can use this algorithm. I won't go much further into that, but we'll look at the flow. So for sharing data, you'll take your plain text, and you'll let's see. Now there's something wrong here. Sorry. You'll first generate a key, like we did all the way in the beginning, and you'll encrypt the data with that, and you get your ciphertext. But then you take your generated key and you encrypt that with the other person's public key, and you get an encrypted generated key, and you can share both of those and put it in the cloud. And then to decrypt, the other person will take their private key, decrypt the encrypted generated key, get the generated key, and then decrypt the ciphertext to plain text. So as you can see, with all these keys, we gotta really stay sharp to not mess it up. Beware, that private key can't just be laying around. So this is what we do with our private keys. We encrypt it with the derived key, and then we can decrypt it again. So if you then look at the whole flow, if I want to decrypt something shared with me, I first have to get my derived key, decrypt my encrypted private key, then I use my private key to decrypt my encrypted generated key, I get my generated key, and I can finally decrypt my text, and I get my plain text back. And this is actually what we usually do also with things we only want to share with ourselves. We do the same flow so that it will be an equal process. So then you just use your own public key when encrypted, and then you do this whole song and dance to get your content back. So authentication, I kind of just skipped the whole authentication part, as you might have noticed. We just put things on the cloud without knowing who anyone was. And the reason for that it becomes more problematic than in a normal web app. Since we use our password to generate keys, the password becomes much more sensitive than in a regular app. So we don't want to send the password, even if it's hashed back and forth between the server to log in. And I haven't been able, and 1Password called this, they've solved this using something called secure remote password, where you never send the password over. You just do a lot of really cool math on both sides, and you're able to say, like, we both know the same secret, but you don't send the password back and forth. But I've not been able to find any services that gives us this, because all the regular backend as a service providers and auth providers, they do regular authentication flow. I found one random package on Node, which, I can't just jump and use that without knowing anything more about it. 1Password has open sourced a Go implementation if you want to try to host your own secure remote password solution. But for POW, I found something else. It's called Blockstack. It's seems to be fairly new framework for creating decentralized apps. So they have authentication on, the blockchain, which is a very popular word to say these days. But I find it to be able to use this for POW is a very practical example of when it's needed. And there they do a similar thing where you authenticate without sending the password over any wires. They also help you with encryption. So if you're just going to do simple encryption, it's much easier. You don't have to work with buffers. You can just encrypt strings like normal JavaScript developers would like. So check that out if you just want to do some fun side projects. So over to the main question: is it possible? So for my use case, it's definitely possible because we can encrypt, and I have made a version of the app. But I think what's more important is that more of us, especially indie developers, start using encryption and really taking privacy first to help our users and educate our users to know when they share and how that whole flow works when you do encrypted apps. And there will always be a trust issue because I could, of course, do things in the browser in addition to encrypting and just sending off the data if I wanted to. And that's one of the things side projects and indie developers, I think, comes in our favor, is that it's maybe easier to get the trust when you start with your friends than it is for the bigger bigger corporations. So maybe we might have a competitive advantage as indie developers if we take privacy seriously. So I would like everybody to just go out and start making your own private apps. And if you want to copy whatever I've made, feel free to do that and let me know how it goes. If you want to see the slides or code or anything, you can go to this address. I'm going to leave it up there for a while. And please come talk to me in the lunch break if you have any questions. And that was all. Thank you. And I also oh, she got lost. Yeah. And I also just want to thank Lillian, who made all of the beaded illustrations. Yes! Mama!